Morning, 8th graders. I decided to make a video of this so you can pace yourselves. Look at the two numbers on the top. 2,540,000, and then this one I've really got to think through. 10th, 100,000, 10,000, 100,000, million. This would be the fraction 8,264 out of 1 million. So what do you notice about these two numbers? Well, hopefully you notice that this number is really big and this number is really small. You're right. So we use scientific notation to tell numbers that are really big and really small without all the zeros. So here's the rule. I know we learned this yesterday, but this is a different way to learn it. We keep the first non-zero digit. So you're going to keep the first digit that is not a zero. And then you're going to place a decimal point before the next digit. So one non-zero digit at the start, then the decimal point before the next. And then we're going to use powers of 10 to correctly represent how we move the decimal point. So hopefully you have some of this down from before. So when we're changing this to decimal or standard decimal notation, we're going to write the first number that is not a zero, which is 2, then place a decimal point, and we're only going to need to write the 5 and the 4. Any zeros at the end can be left off. If they're in the middle, you have to go until you have only zeros. And then it's times 10, and we're making this big. We need to figure out which way. 1, 2, 3, 4, 5, 6. So initially this was at the end. Remember, if there's no decimal, put it at the end. This would be to the 6th power. I know it's positive 6 because it's a really big number. I know this one is going to be a negative value because it's a really small number. I'm going to write the first digit that's not a zero, which is the 8. I'm going to put all the other numbers that are not zeros. It's going to be times 10. I'm moving the decimal behind the first non-zero digit, and I'm going 1, 2, 3 spaces. Since it is a very small number, it's negative. So big numbers, positive, small numbers, negative. When converting a number into scientific notation, if you move the decimal to the left, it's positive. Now that's kind of neat how they made the left part of positive. And when you move to the right, it's a negative exponent. Isn't that cute how they use the G for right and negative and the T for left and positive? I think big and small. I don't think left and right. So practice this one in scientific notation. You can pause the video and work ahead of me. So working that, I need to write the first non-zero number, which is a 3, decimal 37 times 10, and then I need to count carefully. 1, 2 places I moved it. I moved it backwards. It's a really small number. So you need to be really careful. I would rewrite all these numbers really big when you're doing a few problems so you can make sure you're paying attention to the loops. That's the most important thing, is to count carefully. So I want you to listen to this. I explained this yesterday, explaining again. If you're moving it to the left, what you're really doing is dividing. You're dividing by a power of 10. So every time the exponent grows, you're dividing by 10 again. If you're moving it to the right, then you're multiplying. multiplying it, spelled it right, by a power of 10. So positive exponent multiplying by 10, negative exponent dividing by 10. That's what makes the decimal move back. And there's a page 2 that's just a reminder. 8 times 10, 800. 5 divided by 100, well then you'd be moving it backwards. So multiplying by powers of 10 grows, dividing by powers of 10 shrinks. This one is multiplied by 1,000, so it's going to move the decimal place forward 3 times. This one is dividing by 1,000, so it's going to move the decimal back 3 times. Multiplying or dividing, positive exponent, negative exponent. So here's your chance to practice. Oh, got a few more notes to take. When you're working backwards from scientific into standard form, remember that the decimal is moving in the opposite direction. I'm going to turn the paper so you can see better what I'm writing. So if the power is negative, you'll move the decimal to the left. Again, I like to think of it as small. And if the power is positive, you'll move it to the right. Now it's our turn to practice. Pause the video for a minute, practice these numbers on your own, and then check your answers. So the first one, I'm going to put a decimal here. 1, 2, 3, 4. This is 5.679 times 10 to the 4th power. The next one, I'm moving it back 2 places. 1, 2. I'm working backwards. 1, 2. So this one would be 0.024. This one I'm going to put a decimal right. Well, there's one at the end that you can't see. I'm going to move it 1, 2, 3 places. It's a big number, so it's going to be a positive exponent. It's 7 times 10 to the 3rd. I don't need to write 7.0. 7 and $7, same thing. So I can leave off the decimal and the zeros. This one, I'm multiplying times 10. I'm going to be moving it forward. So this would be 16.5. This is a small number. I'm only moving it 1 digit though to get it behind the 9. So this would be 9.3806. You need to write this 0. You need to copy it because there's a non-zero digit after it. Times 10. And we're only moving it back once to the negative 1st power. And the last one, I'm sure too big for your calculator to be help. It's got a decimal here. You're moving it 8 places. Well, I can't even fit that here. I'm going to have to move it over. Oops, move it over this, make it smaller maybe. I'm going to move it 8 places. 1, 2, 3, 4, 5, 6, 7, 8. So there's 3 that are not 0, so there need to be 5 that have 0. 1, 4, 6, 9, and 5 zeros. Then I'm going to go backwards, work in sets of 3 and put commas. So this is 146,900,000. That is a really big number. So after watching this video, you should be able to do some on your own. We can keep these in our journal if you'd like. Not necessary. I just wanted you to hear it another way. Hope that helps.